Very good afternoon to all of you. Very warm welcome. We want to talk about machine learning techniques as we are discussing after midterm exam. To my understanding, you all have done good. You have done well in the midterm exam, and today's discussion will be more on classification and logistic regression. Our target is to talk about, classification task, building a classifier and evaluating a classifier. So take a look at customizing mushroom, and it's basically classifying mushroom, how you can classify mushrooms based on its data. So if you look at classifying iris plants generally these are the flowers, has different types of properties. We know the features: iris setosa, iris versicolor, iris virginica. There are three different types of petal shapes, and you can see the petals here. And we have this data. So suppose we give a new iris flower, it will try to understand which particular class it belongs, maybe iris setosa, iris versicolor, or iris virginica. So classification task, if we talk about, we primarily talk about, we have given a set of class, and there are a set of instances. And the primary task, if you take a look at this picture, we have a classification of degrees versus ages. And we have a target class, we have non-target, and some specific model we have. So what we have to do, given the set of instance and the classes, we need to generate a method that gives a new instance which class it belongs. That means if I give you an unknown instance, my classification model will be able to tell which class it belongs. All right. So let us proceed to see further. So what you give a set of class and a set of instance. What you generate a method. That instances are actually described as the features or attributes and their values, and the class is the finally we call label. That means input is a set of labeled instance. All right. So these are the possible features we can have. We can see 22 different instances. We are having different features, and we try to classify them according to the description. So when we describe an instance, we have a class value, we have class shape, class source. So different data sets has different types of properties. We understand looking at it. So iris classification, it's a continuous feature value. We have the sepal length, sepal width, petal length, petal width, and different classes. And these are actually continuous feature values. So you describe different instances like this. And common classification task, you see, you give a label instance, you generate a model. That modeler develop a model based on which you actually classify unknown instances. An example of a model is a decision tree. As you see that the decision tree is ultimately, the leaf nodes are different classes, and in between you have different nodes are having feature values, and based on the feature values you reach to a decision of a particular class. So note, these are actually attribute-based decision. These are the branches, alternative values, and leaf finally ends with a class. So you can see here. So when we use a decision tree, we give a new instance, it takes a path and travel and reach to one of the leaf node, and which is the ultimate class. So high-level algorithm to learn a decision tree generally start with a set of all instances, and you try to look at it, you try to iterate until all nodes you come to a leaf. So how do you classify a new instance? Now what happens, a new instance comes into, based on this model, you give a new instance is given to the classifier, and new instance classifier identifies which class it belongs. So you can see different classes. So there are two sets we have while we are actually developing the model. We have a training set and test set. Training sets, these are actually training instances, and the model ultimately comes up with a model. So training set, generally we prefer 70-30 or 80-20, but 70% of the data used as a training set to develop the model. and the rest of the 30 or 20% of the data work as a test instance of test set. Testing is very important, based on which we actually measure the performance of the classifier. So what happens when you are actually giving a training and testing, this should never happen. That means there is a zero intersection between two sets. They don't have anything common. All right, so contamination is if you have an overlap between training set and the test set. So about classification tasks, classes must be disjoint. That means each instance belongs to only one class. You cannot have any instance that lead to two different classes. Classification tasks are binary. It's actually binary class, mainly two class problem. And classification method will rarely be perfect because you may have chances to make a mistake in the classification. So building a classifier, what you do, you have a modeler. And what is a modeler? It is a mathematical or algorithmic approach to generalize from instance so that it can predict about the instances which is not seen before, and its output is called a model. So what happens, model actually is a mathematical representation of a pattern which is hidden in the instance, and based on this pattern the new instances are classified. So types of modeler, we can have logistic regression, naive-based classifier, support vector machine, decision tree, random forest, kernel method, genetic algorithm, neural network. But you can understand every modeler or every approach has its own pros and cons, and application areas are different from each to other. So you already have seen the decision tree, a kind of explanations. When it comes to logistic regression, you can see it's more like a pattern. You have a very clear understanding of logically, but some of the patterns are overlapped. You can see it's more like a boundary between instances. When it comes to Gaussian kernel, it becomes support vector machine. You have a neural network similar to logistic regression. Random forest may be covering more different approaches compared to decision tree and logistic regression. You can see that how you have different logic applies in these different classifications. And coming back to our discussion of what modeler to choose, it depends on what type of problem you are actually trying to solve, and data scientists try different modelers. Sometimes we mix models with different parameters and check the accuracy to figure out which one works, because what you have to do for a specific problem, you apply different classification technique and find out which classification works better for this particular problem based on accuracy, precision, recall, and other measurements we are going to talk now. So ensemble is a method. Ensemble is very important for our final exam also, just for a representation. Ensemble is a method which uses several algorithms that do the same task and combines the results. So what happens? We have different modeler. From the same instance, we create actually different models and combine them together, ultimately to have a very powerful classification. So the combination function that joins, we have a majority vote. Each algorithm gets a vote. Weighted voting, there are two types: majority voting or weighted voting. Each algorithm's vote has a weight. So when you decide on a specific model, it depends on, again, what particular problem you are solving. But ensemble is very powerful. Why? Because you can actually combine different models together to form one very strong model. And while you are actually combining, you may have a majority voting or weighted voting. As a particular pattern, you can see different classification features are here. We try to combine them. We have a combined feature vectors and ultimately ensemble based decision boundary. You can see very nicely separated decision boundary, which helps very strong classification, and we have less, more accurate classification and less problems. So how do we evaluate a classifier? We have come to this point to understand that I'm applying a classification technique. Which one is better? So if you see, first thing we measure is accuracy. Accuracy is percentage of correct classification. So how do you look at accuracy measurement? Accuracy, total test instance classified correctly divided by total number of test instance. That means when you measure accuracy, you first see that how many test instances are correctly classified and what is the total number of test instances. You divide, you multiply by 100, you get percentage. So n-fold cross-validation is a very important technique while you are evaluating a classifier. Suppose you have m level instance. M level instance is divided into n subset. N-fold means you're talking about n subsets and of equal size. So what happens? All sizes of all subset size is equal, and you run the classifier n times with each of the subset, so that you actually do first iteration one subset, second iteration another subset, third iteration another subset, and so on, and finally take the average of all subset testing, and finally you produce the output result. So what happens? You come up with a confusion matrix. Now confusion matrix, it talks about how much confusion do you have in your classification model. In confusion matrix consists of actually 4 values. You can see classified positive, classified negative on the upper 2 columns, and the rows you have actual positive, actual negative. So you have true positive, we sometimes say TP, true negative TN, false negative FN, false positive FP. So you basically have a count of how many true positive and false positive. What is the difference between true positive and false positive? True positive means what is supposed to be positive is positive, and false positive means is saying positive but is supposed to be negative. Same goes to false negative, means it's supposed to be positive but it is saying negative, and true negative means it's supposed to be negative and it is negative. So you have a count TP, FN, FP, TN. So you calculate precision and recall. Precision is talking about how accurately it can classify. True positive over total true positive plus total false positive. And recall means how much it can remember. So true positive over true positive plus false negative, because false negative means some of the positive became negative. That's why you're calling it recall. And precision means how accurately it can classify. So there are other metrics also in order to evaluate a classifier. There are many other accuracy metrics. We sometimes use F1 score. We sometimes say receive operating characteristics, ROC curve, and area under the curve, AUC. So other metrics like F1 and ROC and AUC, extensibility of classified result, cost of example, cost of feature values, labeling, cost because the time is very, very important and we have to save time. So what affects the performance? Complexity of task, large amount of feature, that is very, very expansive, and feature appears to be very few times, sparse data, few instances of a complex classification task, missing feature values for instances because that affects the performance, error in attribute values for instance. You have to have a very fine data pre-processing strategy, errors in the levels of training instance, uneven availability of instance in the class. Now coming into some of the very challenging issues, one is called overfitting. What is overfitting? The overfitting means you have trained so much and it is all the time is accurate, and it may not actually give you correct result. Why? Because the model overfits the training data when it is very accurate with that data and may not do so well with new test data. That means you train, your data is biased, your data is not imbalanced, your data is kind of imbalanced data set, and in imbalanced data set chances is high that you have too many positive than too less negative. In that case your model is overfitted, and since you take a look at the training data here, the model 1 you have a kind of separation. In the model 2 you can see there is an overlap between this. So you can understand pretty simply that if it is an overfit, you give new data, you may not get the right result accurately. So induction is sometimes very, very important. Induction requires inferring general rules about seen in the past, and classifiers actually use induction. So they generate general rules about the target class. The rules are used to make predictions about new data, and these predictions can be even wrong. So when facing a classification task, what features to choose? Try defining different features. For some problem, hundreds or maybe thousands of features may be possible. Sometimes the features are not very observable, that is their latent variables. Why we are talking about it? Because when we are deciding on features, we must have a very clear scientific background of selecting features in order to ensure that my classification model works better. So what classes to choose? Is it edible, poisonous, edible, not poisonous or unknown? How many level example? What modeler to choose? So we may have to try different modeler and measure their performance and come to a decision finally to reach to a point. So what are the summary finally? We talked about classification of tasks, how to build a classifier, and how do we evaluate a classifier. I hope you guys are putting your best effort to look into this, and the summary of the major concept we talked about today is instance, feature values, classes, disjoint classes, level, binary task. We talked about learning, decision tree, modular, ensemble method. We talked about induction. We talked about training and test set. We talked about evaluation, class accuracy, confusion matrix, precision and recall, n-fold cross-validation, overfitting. We talked about the data also, that how these features plays a very important role, the significance of features in the classification task, high dimensionality, sparse data, continuous and latent variable. So we stopped right up to here for today. In next class we talk about pattern learning and clustering. I hope you guys take a look at it again, review the topic, and we discuss the final exam preparation also in the next class. Wish you all very, very good day. Bye for now. Allah Hafiz. Bye bye.